Hey guys, today I'm going to show you how to determine the point of inflection for any cubic function, because sometimes the examiner will just say not sometimes, always the examiner will just say determine the point of inflection, right? The examiner will just say determine the point of inflection, and then in order for you to determine the point of inflection, you just need to know how to apply first prime, second prime, right? You just need to know how to differentiate, how to apply differentiation, right? So let's go for it, guys. You are going to apply your first prime. You just need to find your first prime from the original equation, then followed by the second prime. Then on the second prime, you are going to equate your second prime to 0, then you solve for x. That x coordinate that you are going to get there, that x value that you are going to get there, that will be your x value of the point of inflection. And then in order for you to find the y value, you just need to take that x coordinate, plug it to your original equation so that you can be able to find the value of y. So that's how it works. So let's apply our minds, guys. So let's find our first prime followed by the second prime. Then we are going to, basically there are two methods that you can just apply to find your point of inflection. You can just make a combination of the turning points, x coordinates of the turning points. Just need to add them, divide them by 2 so that you can be able to find what? So that you can be able to find x coordinates, because a point of inflection is a midpoint of the turning points of the graph. So let's apply our first prime followed by the second prime so that we can be able to find the point of inflection, x coordinate of the point of inflection. So we have our f prime. This is our first prime, right? So exponent multiplied by the coefficients. Our coefficient is 1, then 3 multiplied by 1 is 3. You put your x, you subtract 1 from that 3. 3 minus 1 is equal to 2. Then 2 multiplied by negative 3 is minus 6. Then you put your x, you subtract 1 from the 2. 2 minus 1 is equal to 1. So here we have our invisible 1. Then 1 multiplied by negative 1 is negative 1. Then 1 minus 1 is equal to 0. Anything to the power 0 is equal to 1. 500 to the power 0 is equal to 1. Even 1000 to the power 0 is equal to 1. So anything to the power 0 is equal to 1. So 1 minus 1 is equal to 0. Anything to the power 0 is equal to 1. So this is just a constant. So a constant, whenever you differentiate, you just need to know that your constant is going to turn into 0. It's going to it automatically becomes 0. So now we have our first prime, right? So let's find our second prime from the first prime. Then this is our second prime. Then 2 multiplied by what? 2 multiplied by 3. Exponent multiplied by the coefficient. Guys, this is an exponent of the power. This is a base, right? Our x is a base. This 3 is a coefficient, right? So exponent multiplied by, during differentiation, it's all about, when you differentiate the equation, it's all about playing with an exponent and also the coefficient. Then exponent multiplied by the coefficient, 2 multiplied by 3 is equal to 6. Then you put your x, then 2 minus 1 is equal to 1, invisible 1, right? Then 1 multiplied by minus 6 is minus 6. Then 1 minus 1 is equal to 0. Anything to the power 0 is equal to 1. Then we have our constant, which is negative 1. So a constant, whenever you apply differentiation, obviously your first prime is your constant is going to become 0, right? So we just need to ignore that. Then from here now we are about to find what? Our point of inflection. Okay, let me show you the point of inflection. Or let me show you where your point of inflection is located. So this is where your point of inflection is located. So this is your point of inflection. This point, it's a point of inflection. You have your TP, you also have your TP. Those are the turning points, right? So your point of inflection, it is the midpoint. It is the midpoint of what? Of the graph. It is the midpoint between this point, which is a turning point, and also this point, which is a turning point. Then from there, okay, let's find the x-coordinate of this portion. In order for you to find the x-coordinate of this portion, which is the x coordinate of the midpoint, right? You just need to equate your second prime to 0, then you solve for x, then you have 6x minus 6, then you transpose. We have 6 equal to 6x divided by 6 both sides, then our x is equal to 1, right? Which means the x coordinate there is equal to 1. Then in order for you to find what? In order for you to find the y value, you just need to plug this one to your original equation. Who is your original? This is your original equation. Then let's plug this one to your original equation so that you can be able to find the value of y. Then we have our y which is equal to, then we have 1 cube minus 3, then 1 squared minus 1, then plus 3. Then what is the simplification of this? We have 1 cube, which is 1. We have negative 3 multiplied by 1 squared is minus 3. We have minus what? We have minus 1, then plus 3. Then this and this will cancel out, right? This and this will cancel out. This and this will cancel out. This and this will cancel out. Even this one and this one will cancel out. Y is equal to 0, which means our y value, it's somewhere here. Which means this one, it's our x value. Here is our 1 is to 0. Our y value is equal to 0. Which means our point of inflection is on top of the x-axis, right? Which means this point of inflection, this x coordinate of the point of inflection is one of the x-intercepts for what? For this original equation, because it's whereby, like it's located whereby our graph is intersecting with what? With the x-axis, which means that it's the x-intercept. Is the x coordinate of what? It's one of the values of this original equation. Then that is the point of inflection, which is 1 is to 0. Those are the coordinates of the point of inflection. Then there are two methods. Then we have a second method that we can just use to find what? To find the point of inflection. If you are failing to find, like to use this thing of finding your second prime, then equate your second prime to 0, you can just find the turning points. If we have the turning points, because this is the midpoint of the graph, right? So if we have the turning points of the graph, then we can be able to find what? This point of inflection. So let's apply our first prime, because in order for you to find the turning points of the graph, you just need to find what? You just need to have what? You just need to have your first prime, then equate your first prime to 0, then find the turning points, right? So after finding those turning points, we are going to take the x coordinates of the turning points, then you combine them, you divide them by 2. Reason being is because a distance from here to this portion is equal to the distance from here to this portion. This is the midpoint, right? This is the midpoint of the graph. For a cubic function, this is the midpoint, right? This side is equal to this side. Then the distance from this turning point to this portion is equal to distance from this portion to this portion. Then let's find our first prime. Like this is the second method that you can just use if you are like if you don't know how to find or let me say if you don't know how to find the second prime, or let me say if you are not given your equation but you are given what? The turning points as the coordinates. Then you are given the coordinates of the turning points, then the examiner says determine the point of inflection. So you can just use those turning points to find the point of inflection. So let's apply our first prime so that we can be able to find the turning points and prove that the same answer that you have got here on your second prime is the same answer that you are going to get by making a combination of the x coordinates, then dividing them by 2. So let's apply our first prime. So we have our first prime. This is our first prime that allows us to find the turning points. So we have 3 multiplied by the coefficient, which is 3. Our coefficient is 1, right? Coefficient of x. Then 3 minus 1 is 2. Then 2 multiplied by minus 3 is minus 6. Then you put your x, 2 minus 1 is equal to invisible 1. Then 1 multiplied by negative 1 is minus 1. Then 1 minus 1 is equal to 0. Then anything to the power 0 is equal to 1, right? Then this is our first what? This is our first prime. Then we just need to equate this first prime to 0. This first derivative, first prime. This first prime, we just need to equate it to 0. Then we are now going to find our x-coordinates of the turning points. We are now going to get the x-coordinates of the turning point. Then let's use our quadratic formula, because this is the quadratic equation. Then let's just use a quadratic formula to find the x-coordinates of the turning points. So we have our x which is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Then our x is equal to minus b minus b. Our b, we have a, we have b, we also have c, right? Our b is minus 6 plus or minus square root of b. Our b is minus 6 squared minus 4a. Our a is 3. How about c? Our c is minus 1, all divided by 2. Our a is equal to 3. Then our x is equal to that. Keep in mind that this x is the x-coordinates of what? Of the point of inflection, the one that we have calculated from our first prime. Then our x is equal to 1. We have calculated this point of inflection using what? Using our first prime, our second prime, not our first prime, our second prime, which was 0, which is equal to 6x minus 1, minus 6. Minus 6, then we have set 6 equal to 6x divided by 6 divided by 6. This and this, x is equal to 1. Right? So this is the method that you have used to find the point of inflection. Then try to punch this on your calculator so that you can be able to find the x-coordinates of the turning points. X is equal to this, or x is equal to that. Our x, let me punch the calculator. Then our x is equal to 2,15. 2,15, or our x is equal to negative 0,15. Then in order for those are the x-coordinates of the turning points. And this negative 0,15 belongs here, because this point is for the negative, this side is meant for the negative x-axis, right? So we have x which is equal to negative 0,15, this point, right? What about this side? This side we have 2,15. That is the x-coordinate of the turning point. Then in order for you to find the point of inflection, you just need to add these two values, because this is a midpoint, right? A point of inflection is a midpoint of what? Of the turning points. So you just need to say x is equal to x1 plus x2 divided by 2, because this is a midpoint. The point of inflection is a midpoint. Therefore our x is equal to, our x1 is negative 0,15 plus 2, our x2 is 2,15 divided by 2. Then what is a combination of this divided by 2? Negative 0,15 plus 2,15 is equal to 2 divided by 2. If you can just punch negative 0,15 plus 2,15 all divided by 2. So the simplification of this is equal to 1, right? Therefore, the answer that we have managed to get here is the same answer that we have managed to get here. So, which means both turning points and also the second derivative, they can be able to help you to find what? They can allow you to find the point of inflection, not the turning points. They can both allow you to find the point of inflection. So that's how it works, guys. Both of them, they are equal to 1. Please don't forget to subscribe, guys. Don't forget to subscribe and also like my video so that the algorithm can push my video, guys.